Welcome everybody to Tuesday night on a real Tuesday. I know I missed last week. Apologies. I was in Regina. You know I was. Anyway, well, I'm back. Anyway, tonight we're going to go to KeeKoPip's Discord server where he's going to give the presentation on interferometry that he didn't get the opportunity to give when he was on Modern Day Debate. So, and he said he's spiced it up a little bit to make it more fun and interesting. The link to join is on, he's on. We're going to see him. Shirtless even. Anyway, or not, sleeveless. He will be sleeveless. Anyway, we're going to say hi to KeeKoPip. How you doing, KeeKoPip? What is going on?
What up?
Let's see. For some reason, I'm not getting your, that's weird. Oh no, that's because my Discord view froze. That's why. All right, hold on. That's probably it. I'll get it. Anyway, how you doing?
Sup?
That's all you got. Sup. There we go. Now they can see you. No sleeves and all. That's what we expect.
I freshly cut these sleeves off.
Yeah? So Sean Wellick that I debated earlier today, obviously if he wants to be an epic Flerf like you, then he needs to, step one, cut off the sleeves.
Yeah, I was hoping to talk to him after that. I mean, he made some pretty, basic TFE arguments, but you should watch my video for the rest of the chroma key stuff.
That's right, Sean. Anyway, KeeKoPip is he's gonna, or KeeKoPip as we like to say too, is going to gonna give the Prezzie that he wasn't able to do because he didn't have time when he was on Modern Day Debate. So, you good? You ready?
Yeah, whenever you want to start.
Yeah. Oh, look who's here. We got Ammon, who was your interlocutor for that encounter. Very exciting. He's in the Discord here.
Oh shit, that's actually coincidental. Was that planned?
He probably had no idea. It's just he just randomly wandered in, I'm sure. Actually, I didn't send it to him. I don't have any information. So, all right. We're ready. Yeah, he just joined the server. So, hey, say hi quick. He might not be able. He unmuted for a second.
Sorry, I'm on my phone, had to figure out how it worked.
Oh, well, there you go.
I had no idea you were doing this until it popped up on my phone that you were live.
There you go. Well, now the thing that probably you won the debate, obviously, but this is probably the part that would have caused your defeat.
Probably. I have no idea how interferometry works.
Yeah, now McDin is going to give you all the good arguments against this.
All right. All right. Well, whenever you're ready, KeeKoPip, this will be great.
I think I'm ready. Before I start the presentation, I just want to give a little intro about myself because I'm so egotistical. I love to talk about myself for a large part of this presentation.
Well, you should put yourself on screen so they can see it.
Well, I got the.
Oh.
Dude.
Oh, you're streaming. Okay, I got it. I'll. There we go. Okay, go ahead. Let the ego go.
Okay. So my name is QOP. I'm the flat earther that made Witsit cry. Subscribe to my channel at KeeKoPip to get notified of my upcoming TFE vid with more clips of Witsit's cries and lies. More info. There's some more info about me. I'm my own lawyer, and I lost my Mount Rushmore case on purpose as a 4D chess move to psyop the Juminati. My blood type is Rh negative. I have control over electronics that aren't even connected to Bluetooth. I have many superpowers. I can astral project to travel the flat Earth. And before people die, I know they are going to die. I am the new Messiah. I thought there was going to be applause after that.
Those are bold claims.
Those are all things that Witspit was saying last night.
Oh, no, I don't know what you're talking about. That's not anything that Witsit was saying.
That was some you joke about having a big ego, right? But the amount of ego that Witspit had last night was staggering. I wonder if anybody recorded it.
Oh, but yeah, back to interferometry.
Okay.
So this is going to be the death of MCToon, the end of his tyranny, and all right. So you got my.
I'll get my. I do. I'll get my facepalm protection ready.
All right. So this is on interferometry, and the two things in. So I'm going to present the history and how the two predictions between the undulatory theory and the emission theory, how that went. As far as this debate, this is between globe, no ether, space with space-time versus flat Earth with ether, no space-time. The undulatory theory versus the emission theory back then were both based on a globe with an ether. One was claiming emission theory, which is pretty much the beginnings of the atomic theory. The undulatory theory was like the remnants of the etheric field theory that our ancestors still kind of held on to, that they were trying to squash. But the thing is, so for the most part, that was an undulation from my belt.
Dude, that's only 3. Come on, do better. I'll give you a 3 on that.
Where was I? So the undulatory theory. So most of the undulatory theories. So the undulatory theory is closer to. Obviously, it has nothing to do with flat Earth. It has to do with the ether. But the undulatory theory is pretty much closer to my position, obviously, because the ether works like a wave and not particles. The modern, space-time with photons and stuff, everything is a particle. So that would be closer to the emission theory. MCToon will say that neither of those predictions really are based on, anything modern, right? It's a little bit. I mean, the results you would agree are the results, but the emission theory isn't really your position, right?
Well, I think it's the dual. The duality is what's pretty good.
Oh, so you're saying like a particle wave duality, so both of them have their merits?
Yeah. It sometimes acts like a wave, sometimes acts like a particle.
Okay, perfect. So, but for the most part, I'll show that the undulatory theory is the one that the prediction for the undulatory theory is the one that was matching up with the interferometry results, and the emission theory was not matching up ever. So the first interferometry test ever was from Young. It was a double slit experiment, the first double slit experiment. It's not really thought of as interferometry, but it is, because they're looking at an interference pattern. So within this, the apparatus is stationary, the beam path is not circulating, and the interference pattern is showing a stationary, no Sagnac effect fringe pattern. So that's one of my main arguments lately. All these instruments that they claim are measuring Earth's motion have to be in motion. The gyroscope has to be spinning. The interferometer light has to be circulating around a mirror path. Within this double slit, the beam path is not circulating, and therefore you don't get the kind of fringe pattern that they get on ring laser gyros, which is how they claim, what they claim is being caused by from the Earth's spin. So my argument is that the only reason you're getting any pretty much a fringe pattern, which is just like a delay in one of the light paths return to the same spot, is because the instrument itself, or within interferometry, the light itself is moving in a circular path to get that started. That discrepancy between the two lights. One is traveling counterclockwise, one is traveling clockwise, and in the globe model they claim that's predicted just because the Earth's spinning, but it doesn't really make sense that the Earth spinning would affect how fast more undulations, how fast the light would travel. So here, got some quotes from Jung.
Oh, question in your notes. Do you insert where to burp?
Yeah, in between slides, so I can get the burps out.
Okay, sounds good.
Yeah, the gaslighting that you do gets me very gaseous. So I don't know why I have these quotes from Jung. Let's see. Radiant light consists in undulations of the luminiferous ether. Oh, so it's kind of interesting that Jung, who set this up, believed that these are all undulations of light. And back then, this is why I add that, because back then they didn't even consider particle wave duality. Jung set this up. He saw the interference patterns and he thought these are just waves. You'll say that more precise instruments that can measure a particle. That's a different debate. Maybe we can get into that. Einstein.
There's a question. The on that bottom line there, where it attributes it to Albert Einstein.
Mm-hmm.
How did you type the M dash?
The dash?
Yeah. How did you type the M dash there?
I don't know.
Okay. All right. That's all. Thank you. That's all.
Because it's too long?
No, it's yeah. That's if you look at the, let's see, where it says the couple up where it attributes that one quote to Jung. You see that?
Yeah.
Radiant light.
That
Yeah.
different.
That's an N dash. Yeah, that's a short dash. Yep. And then the one in front of Albert is an M dash. Just a different type of. It's a typography thing. I used to write typography software, so it's things like that I notice. Some other people notice those too. So anyway, that's all. I'm sorry.
I hope you don't hear the rain too much.
I do. It's very calming.
If you want me, I can turn off noise I can turn on noise cancellation if it's annoying.
Well, Patch Van Braun says this is so much better with all of the sound turned off. I don't know if that would be that good, but
You want me to close my mouth too?
No.
I'll read this slide.
Much better. Much better.
all right.
I like it.
Or NASA Chill could just give the presentation and say the ether was debunked by Michelson-Morley, and that's it.
Well, it was, but anyway, we're here for the fun.
And,
NASA Shell, let him do his stuff.
Sorry.
So yeah, thanks, NASA Shill. So Fizzows, it's actually Fizzo.
There you go.
Fine.
That's right.
1851, moving water interferometer. This is I believe this is the first real interferometer setup. This is actually not even Fizzo's idea. I think he got this from Fresnel. But it's pretty cool. It's got moving water alongside in one direction. It's got that going counterclockwise, the water. And then the two light paths are going clockwise and counterclockwise. And then what they noticed is a velocity addition for the one going with the water. So the undulatory my service is a little low. Am I still coming through?
Yeah, you're dropping a little bit here and there. Not terrible. All right, keep going. Well, it is getting a little.
Let's see.
It's dropping a little more. I don't know if it's you doing something or not. Are you trying to change something?
If I stop streaming it, I'll be able to talk better.
Okay.
Well, I'm going to be lagging if I keep streaming the slides while I talk, so it's probably better I just talk.
Okay.
Because then now my thing, I got all the bars on the Discord. So on the yeah, so I'm gonna get Starlink soon, so eventually I won't have this problem. I'll be using the space satellites for internet.
Yeah.
A flat earther using satellite internet.
Why-
That's hilarious.
That is ironic.
Very, very funny. So with this moving water interferometer test, the undulatory wave theory prediction was that moving water should partially affect the speed of light. The change should be only a fraction of the water's speed. And then the emission atomist theory with the ball particles prediction was that light particles should simply have the water speed added to their own. So the amount of change of the light speed was matched the undulatory theory. So
In the one diagram, the light, what was it, split diagonal so that one path went through the water traveling one direction, and one path of the light went through the water traveling the other direction?
no, I think only the water was set up so it's only affecting the one go. Wait.
It looked
So
to
the one that's either way, the both theories are claiming that there should be some, a certain amount of fringe shift. So the counterclockwise light path is supposed to be a little faster, but
okay.
at different rates.
All right, and what was the result of the test?
It matched the prediction for how much of change there should be for the undulatory theory. So
Okay.
it should only be a fraction of the water speed, and not have the water speed added to their own, which would be a lot more.
Okay.
I believe it's because they claim the particle. Actually, I forget why they claim the particle would be sped up more.
Do you have your presentation somewhere that I could display for people?
Well, I got green again, so let's see if I keep going. I wish I'd lower the quality even more. Okay, so this next interferometer test was Foucault's rotating mirror interferometer. The emission theory was predicting the speed of light in water would be greater than the speed of light through air. The undulatory theory predicted the speed of light in water would be smaller, not as fast as the speed of light through air. And then Foucault measured that light travels slower in water than in air. So that was what the undulatory wave theory was predicting. So basically, Einstein, many years later, 40 years later, his ad hoc theory was that he basically just took Maxwell's equations and then he reified like his space-time field and claiming that the wavelength, I don't know why I added wavelength ether medium. Oh, I was writing here that the Maxwell's equations were assuming the ether to be moving like a wave. So it's kind of weird that he just took Maxwell's math and then he claimed that there's no ether waving of the light, that there's basically just a space-time field and light particles. I think my connection is dropping off.
So I could show them.
The slides?
Well, I took a screenshot of your slide so that I could show it. What if I do that? Here, let's get... Yeah, all right. So you don't need to share. There you go. Okay, so here is your Foucault rotating mirror interferometer that I'm displaying on screen. So I just took a screenshot of your Prezzie. So there we go. So, but where are you at? There you are. Okay.
I just screenshot. I just screenshotted the rest of the slides, so you can I'll just DM them to you.
Okay. That works. Clive Weld says Maxwell's equations are already consistent with special relativity. It was the first relativistic theory. No surprise. Potato Tron says Austin isn't using his old skin suit. Oh my goodness. God Oblate Severoid says I have 1,800 hours flying lighter than air aircraft, but cannot find a job as a Satelloon pilot. Anyone know where I might apply? That's amazing. Yeah, definitely. You should get that job. Blackburn Big Dragon. Oh yeah. That's 100% true. I should let's see. Regular am I getting? Yes. This. So it turns out in my config, if you're familiar with it, I capture all super chats and I capture a subset of regular messages if they have my channel name in it or a few other things like Witsit. So if you want me to get it captured, then you can type Witsit. Also QOP is in there and Fakatsoid. So those will show up and I can display them on screen here like this one. Just like that. So, okay, here we go. He's sending them to me.
Yeah, those are them. The next three in order.
All right, that'll work. And that's a better
Yeah,
quality
crazy,
than my screenshot.
It's crazy how much my service goes down from just screen sharing the slides.
All right. Downloads. Sort by date. Oh no, wait. Where did I put them? Oh, I put them in the QOP folder. Of course. Instead of the there it is. Oh my goodness, where did I put those? All right. I'm putting them in the wrong spot. I'll start over. Here we go. All right. 1, 2, and 3. All right. Okay, so I can put those on screen, whichever ones you want.
Yeah, put the Aries failure one, and then the Michelson-Morley after that, and then the space-time one at the end.
So, okay, yeah. Arago and Airy, that one?
Yeah.
Yeah, all right.
So yeah, so this Arago test was like the first time they used a water-filled telescope to check out aberration. And then Aries failure was like the last time, the next time that they reattempted to try and so like the aberration nowadays, like, you know, MCToon will claim like this is predicted, and they adjusted like the heliocentric model to account for the aberration of stars on a cyclical yearly basis. But back then it was a problem, so that's why Aries was trying to set up a more precise water-filled telescope with I forget who used turpentine. One of them used turpentine and one of them used water.
Airy used water, to my knowledge.
Then turpentine might have been Arago. So back then the emission, you know, they had the emission and the undulatory theory predictions. The emission theory prediction was that stellar aberration should change when viewed through a telescope filled with water. The undulatory theory was that light is only slightly dragged by the water, since light is traveling through the ether medium, which causes only a fractional amount of drag, and the result was no change in stellar aberration, which matched the wave theory for looking at stellar aberration, which is just looking up at your zenith with a telescope filled with water. So then when Aries did it, he basically just did it again, and they got the same thing, no change in stellar aberration. So Einstein replaced these with relativistic velocity addition formula, and then also basically he claimed that the relativity of simultaneity theory, which is basically like there is no simultaneous now. There's like relative nows that are reference frame like dependent, like based on like your inertial frame, which is just claiming that like because things are in motion, you know, the speed of light is basically it's all like they claim the speed of light is the same no matter where you are, but from the different reference frames, you know, you got different. They could basically just adjust. They just take like an ad hoc velocity addition formula, and they just adjust what they need to make it match their model, basically. So then the Michelson-Morley slide, you want to pull that up?
Yep.
So this is a little. So Michelson-Morley was they were actually trying to detect Earth's motion with this interferometer test. So up till this point, you know, they had all kinds of different interferometers. They weren't testing to see if the Earth was moving. But now all of a sudden, when Michelson-Morley does it, somehow the interferometer becomes something that can test for the Earth moving. And within the, I screenshotted a little piece of the Michelson-Morley paper, and that's where you see it says the prediction for the, you know, the Earth moving, the globe Earth moving through the ether wasn't what they didn't get as much of a fringe as they expected. It says the quantity to be observed, namely a displacement of something less than a 20th of the distance between the interference fringes. so less than a 20th of their prediction. That's what they got for as far as the fringe pattern from this test. So this is basically, so that back then that was a, that was a problem, and then Einstein came in, and now ring laser gyros have that same fringe shift pattern within the interferometer in the ring laser gyro, and they, they have all these kinds of corrections that Einstein basically gave them, and now they claim this is, this that gyroscope is measuring exactly how much fringe shift should be caused by the, latitude dependent, drag effect on lights, which is accelerating, light in. So within my belief, the ether vortex is spinning, and so at different latitudes, your light is being accelerated, faster in one direction than another, which matched the undulatory theory more, and it makes sense within like electromagnetic physics that that there would be an effect on light like this. So as far as motion of something causing light to accelerate faster around us, going in a certain direction around a gyroscope, I mean a ring laser gyro, or like this interferometer test, it just really just doesn't make sense. And then you want to pull up the last slide.
Sure.
So this is pretty much just going into like Einstein's, space-time field. It's on the left, that's just a drawing of a space-time field. There's no actual, there's no one's ever seen the geometry of a space-time field. There's nothing that captures the geometry. The what do you call this? This like sagging, like a vortex. He's got like a half vortex there. I guess with like the wormhole theories and stuff, it completes like a full. It would complete the full like hyperboloid of a toroid geometry, which is what you see on the right there.
What? Hold on. An actual. Wait. What's on the what part of the one on the left are you talking about?
What part of the space-time field?
Yeah. So you're saying something about a hyperboloid.
Yeah. So if I take this and I copy that whole image with the space-time field, right?
Okay.
And I duplicate the same thing, and then I flip it around and I connect it with the little parts connected, like a what are those timekeeping devices that are kind of like shape of an 8?
The timekeeping devices that are the shape of an 8.
Hourglass? Yeah, like an hourglass.
Oh.
So if you create like an hourglass shape out of this space-time, you basically just get a hyperboloid, which is what you're looking at in the ferrocell on the right there, which is the actual geometry that Einstein basically took from ether physics, which, like I was showing, that's just the history of the undulatory theory matching all the predictions throughout interferometry.
So a question, the lines that you see on the right side there on the ferrocell, like intersecting with each other as they get closer to the center, what is causing the visible lines?
So as far as like how you see those lines, or within like the field,
what is causing those distinct lines to be distinct?
So the magnetic field is basically has, I guess, ley lines through into the vortex. So the I believe there's little microscopic iron filings of some sort. It's called ferrofluid. I'm not sure.
Yeah, exactly they put iron in there. Here's what's actually causing it. The LED lights around the perimeter are causing it. So if you have more LED lights around the perimeter, there will be more of those lines, and if you have less, there'll be less of those lines. And if you had basically a very consistent non-independent light base, like it was just a bar that was all the same intensity, there would be no lines visible at all. You're just seeing artifacts of the fact that there isn't a consistent source of light around the perimeter. There's not ley lines in magnetic fields. Those lines are caused by just having discrete LEDs.
Yeah, I was just coming up with a theory of exactly how the field is creating the lines is. But as far as like so you're saying the lines will all turn in, like the whole thing will be white, but you'll still get the little black hole there, right?
There will be variations in the intensity of it based on the polarity, but you won't see lines.
Okay, yeah, sure, but the black hole at the center will still be black.
Yes,
no matter what.
And that's because
that's
it's because of the polarity. And so what you're seeing there is this is probably just it's a facet of how light is propagating through this polarized medium. That's because that's what this is. It's not, you're not seeing whatever. Okay, go ahead.
okay, but like so you're saying that, I mean, there's still, like, whether or not like that's the amount of lines that, whether or not like those lines are like static, that they're still showing like the warping around like into the vortex. Like you're still gonna see. I've never seen what you're talking about where like there's no lines at all.
Yeah, you probably haven't, because having a consistent light source like that does not have discrete sources is difficult to do. You'd have to have several techniques to make sure that the distribution of light was consistent. But if you, for example, if you just removed one of those LED lights, then you would see that its circle get removed. Those are not intersecting or like spirograph lines. Each of those is an independent circle, but you don't see all of it. You just see a portion of the circle. So,
well, I mean,
so this one, this isn't the best one to see that with. Some of the other ones that are floating around, you can actually just draw, like, take one of the lines, draw a line, like highlight it, and you'll see it loops back to itself. And then do that to all of them. And all it is a bunch of overlapping circles. They're not doing a spirograph pattern. They don't connect as one, like, looping line. It's all independent lines, and the number of lines is directly related to the number of LED lights. So anyway, that's all. That's all.
I mean, I've never seen any. I mean, if you got any pictures of a ferrocell that shows no line, that like a fully bright area around the black hole area, I'm not sure what it would even look like without lines.
Yeah. Well, I mean, I can imagine what it would look like, but let's see. I may have a. Yeah, let me see here. I have a folder there. Okay. This is good. All right, let me grab this quick, and then I'll drop it into the chat here so that you can see it as well, because I'm not sharing my screen to you so let's see here. There it is, that one. Okay. Ferrocell circles is what it's called. Okay. And I'll drop it into the big chat here on your server. And there you go. All right. Oh, Earth is Life dropped one in. Yeah, so if you... Earth is Life's version is pretty good too. And people, if you're on the Discord server, you can... Oh, I'll there it is. Earth is Life is pretty good too. So if you trace any of those lines, you'll see that they're just a bunch of circles. And the circles just loop to the other side of the center of the cell there. And so that's what you're seeing is that the inside of all of those lines are all coincident in that circle in the middle there. So now, on the other hand, Austin Whitsitt or other flatties like to claim that this right here is the same pattern, but it's not. You'll see on these, this is one line that's looping, a single line. And on these, it's a bunch of different non-connected circles overlapping. So anyway, that's beside the point. It's not really pertinent to directly to your thing here, but and by the way, these the ones that say Mercury, Venus, Mars, Jupiter, Saturn, Uranus, those are the patterns of the planets in the geocentric globe, with the planets being millions of miles away idea. They are not the path of planets over the Gleason map, not even remotely similar. So anyway,
how would you get only one? How would you get a view of all of them if it was over a globe?
how would you get a view of all of them?
Yeah, over
flat Earth?
You're saying these are over a geocentric ball Earth model?
That's well, yeah, and each of those paths is many millions of miles away from the Earth. So, some flat earthers like to take these geocentric globe patterns and drop it over the Gleason map and say that's the pattern that they trace in reality, but they're not. That is not the tracing of the GP of the planets on the Gleason map. Not even close.
But these would be positioned over like the North Pole of the globe.
Of the globe? No, this is. It probably would be in relation to the plane, the ecliptic plane, and would be around.
They're all going in a circle, right? So
yeah, so like it would be relative.
On top of the globe, with them all going around the North Pole.
Nope, not the North Pole. Around the ecliptic pole. The ecliptic pole and the North Pole are not the same. The ecliptic pole is angled from the North Pole.
But it's still
on the globe.
It's still not. This is a visual from top down to the North Pole, not
the North Pole. The ecliptic pole. There's a difference. There's a very, very important difference between the ecliptic pole and the North Pole. But that's what this is in relation to. So.
Okay.
That's all. It's not critical. So anyway, there you go. All right. Was that it, or you got more?
Yeah, that's pretty much it.
Okay. All right. And so, what's the conclusion that we are to draw from this?
Well, like I said, the undulatory theory was the wave theory. The predictions were all matching up, and then when they tried to test for their prediction for the globe Earth moving with Michelson-Morley, they just got like a null. They didn't get the amount of shift that they expected. So that all works within like a flat earthy theoretic like model. It's the ether was constantly validated from the undulatory theory being validated, and then the Earth not moving was validated with Michelson-Morley. And then all Einstein did was literally just rework, mix everything up, add the undulatory with the emission, and then add some velocity corrections, which the math comes from Maxwell. And
what velocity corrections?
Call that all globe physics now.
Which velocity corrections? I'm trying
to velocity addition formula. It's called.
Is there?
Within it's like within one of either general or special relativity.
Okay, I
believe it's just from Maxwell. I think it's just a Maxwell formula.
Do you remember the Maxwell equations?
It might be his. I don't like math, so I don't really. I like the theories and the science.
Oh, yeah.
But I know that Einstein didn't do any interferometry tests himself, so this is all ad hoc. So the math,
Well,
how he how he mixed everything together and how he explained everything is irrelevant to like what's actually going on with the interferometer. So you're just getting one beam is arriving sooner than the other, and that's just there's clearly a reason one of the light paths is speeding up. So you guys claim neither is speeding up, pretty much.
Yeah. So, anyway, okay. I think I have something maybe a little interesting to. And I think what I'm going to do, I'm going to try to share my, my screen here. So let's see if I can. There it is. Okay. You see the screen here?
Yeah.
That I'm sharing. Okay. So this is to show, on the AE map, right? You've got the North Pole, you got the equator, you got the, South Pole, I guess.
I wouldn't call that the South Pole.
And then these circles are showing the, if you use a ring laser gyroscope that is horizontal, because in an airplane, they're typically in three axes. But if you just use the horizontal one, so you can get that by using, you can purchase a single axis one, or you can use a Foucault pendulum. But anyway, so the size of these circles is meant to indicate the magnitude of the change, right? The magnitude of the measurement. So near the North Pole, right at the North Pole, though to my knowledge it's not been tested there, but in the farther north you go, the larger the reading is for this horizontal optical gyroscope. At the equator, it measures 0, and then it increases the other direction, increasing as you get farther away. And so we see the same effect with hurricanes, in fact. They go one direction north of the equator, one direction south, and they're more intense when they're really close to the equator, they die out and don't cross the equator, just go to nothing. So anyway, so if you're saying that there's an ether vortex that's causing this, then I just want to know how is the single ether vortex causing this to happen, and why at the equator is it gone and there's no effect?
So you're saying at the equator, both beams are getting around at the same time?
Yes. On a ring laser gyroscope, the fringe for a horizontally mounted ring laser gyroscope is zero deflection in the fringe.
Okay, and why? Yeah, it's hard to to visualize. I'm still trying to visualize everything, but I'm mostly trying to figure out the globe model, the geometry of the flat Earth of like what I believe is going on is way simpler as far as like how the interferometer is in relation to the Earth and the vortex above, and its power at different latitudes and the equator. That makes sense to me. But as far as the ring laser at the North Pole is basically measuring more of a drag, right?
I don't think anybody suggests it's measuring a drag. There's a shift in the pattern when they're recombined.
That's what the drag. That's like a drag effect, that the light is dragged. The other one of the light paths is dragging slower or faster.
Okay, I guess you could say it that way. So okay,
So there's a more of a discrepancy at the North Pole and the southern.
Yeah. So I'll draw a ring laser gyroscope here, kind of the way it's often done.
isn't the equator spinning the fastest in your model at that location? Like that's where the fastest speed is.
Yeah, yeah.
That's why I don't understand like how like that doesn't make sense to me. That for you guys the I think the fringe pattern should be the greatest discrepancy at the equator because that's the one spinning the fastest.
So, all right, here's a sample ring laser gyroscope. You've got one light path going this way, right? And then you've got another light path, I'll do in blue, that's going the other direction. There you go. And then they recombine here. So you got a laser here that I won't draw. And then you got the blue and the orange recombine. And if they're out of phase with each other, and say they you know, they shine on a wall, they don't, they do it more fancy than that now, but they'll create these like if they are in phase with each other, they'll create a single dot. But if they're out of phase with each other, they'll create like a target that would look like, you know, maybe if you dropped a rock on a surface of water and the waves rippled out like that. This is what you'd see on that wall when the light is recombined. So that's how it works, right? So the light goes in two different directions. So what the globe is saying is that this is measuring the change in it's measuring the rotation. And that's because from when one of these lights started moving this direction and the other one went this direction, while the light was in flight, this object rotated and it made the path longer one direction and shorter the other direction. So now the you know, when the light left, this wall was here, and then a little bit later, just a millisecond later or whatever, the wall has shifted in position. And so the light path one direction got longer, the one got shorter the other direction. But now you're saying that it's not rotating and that something is causing this, even though it's not rotating, you're saying, to make one path go faster than the other path. And you're saying it's the ether vortex doing that. So that's why I'm asking, why at the equator is it 0 if there's an ether vortex, and why is it the opposite direction on the other side of the equator?
Well, see, that's the thing with at least my position. I don't feel like I need to know everything yet, because especially since I want to find out the truth, I'm not gonna just guess at what the truth is. But there's clearly like something going on at the equator that makes, you know, satellites able to be geostationary and stuck there. Tornado, you know, hurricanes can't cross. You don't have as much of this effect in the equator. But so that's fine. I think there's some crazy anomaly going on with this vortex, and it affects things differently depending, you know, how far you are from, you know, north and south of the equator, blah blah. But so like as far as like in the globe model, right? The equator is the part of the ground on the ball that's spinning the fastest, right?
Yes.
Okay, so if you're moving a ring laser gyroscope faster, you're going to get more of a fringe pattern, right?
It depends on the orientation of the ring laser gyroscope, and the ring laser gyroscope is measuring rotation, not velocity.
Okay, but how would the interferometer, you know, circulating in there, tell the difference between rotation velocity and just like surface velocity?
Well, nobody has figured out how to make a ring laser gyroscope or ring laser interferometer or any sort of interferometry to measure linear velocity just in itself, right? If you need to look external, but it can measure the rotation. And like I said, when the light leaves the laser, like here, the entire device is here, right? And so the mirror, and then you have to imagine when I draw this other mirror spot, that the entire apparatus rotated with it, so that both the blue and the orange lines now show up up here, or not up here. They arrive at different times because one had a longer path and one had a shorter path, because the device rotated while they were in flight. But if you take the entire device and shift the entire device, that doesn't make one path longer and one path shorter. They're both of the paths are the same distance if you just shift it side to side. That's what it's doing. And so there's nothing that we know of that can measure a linear velocity like that. So anyway, that's it's called the Sagnac effect, and that it's because one is moving faster than the other. But then it's back to this, this ether thing, or this ether vortex, that many flat earthers, I mean, you're not the first to say this, have said there's an ether vortex, but none of them have ever addressed why is it like this.
I know I can come up with theories, but that's not really like, I don't have a concrete position. So before I forget, what was I going to say? So you'd agree, like within the ring laser gyro interferometer, the path, the distance inside the interferometer that each light beam has to take it stays the same, right? No matter where you are on the globe, flat Earth, whatever.
What stays the same? The distance?
Like the size of the interferometer path for the light to travel through. It's remaining the same. It's not being affected by anything.
The length of the path changes for within the general and special relativity idea and the globe rotating idea, yes, but it changes. So not yes, I guess, to your thing. The path of the light does change.
I'm asking the instrument itself, like it doesn't change size. So neither side of the interferometer is getting all of a sudden bigger or smaller. It's the same distance that the light has to travel, whether it's going counterclockwise or clockwise.
No, it's a different distance.
Within space-time, you're saying that space-time, the velocity or the motion component is causing the interferometer to change shape?
The interferometer is not changing shape.
Okay, so that's what I'm saying. So that it's not changing shape. So the distance that each light beam has to travel to get clockwise or counterclockwise around it remains that they're both equal, and they're not changing no matter where you're on a globe or anything.
Say that again. I got to focus.
The interferometer is not changing no matter where you're on the globe, and it's the distance that the light travels counterclockwise or clockwise around that to get to the same spot and check, which one was faster. It shouldn't be affected by anything on the globe. It's the path, the light itself is just traveling at the speed of light. Each of those ways, there's no water, there's no different mediums. They have the same medium within the ring laser gyro. They should just get, like, despite, like, no matter what's going on the globe, if it's spinning or not, these paths of light, these lights have nothing. They don't care about what's around them. They're within the instrument itself, going around the path. It's not changing shapes, unless you're saying Einstein claims that they change shapes. I know he says that about Michelson-Morley. I'm not sure how that works with the laser gyro.
No, he didn't claim that they change shape or change size. It's just that the device changed its position. It got longer one direction than the other. Einstein did talk about
what got longer?
The path got longer.
But the path within the interferometer and the ring laser gyro is within a very rigid, instrument. It can't get longer.
Oh my gosh, I don't know what you're talking about.
If you're measuring the Sagnac effect, which means that the pattern, the fringe pattern is showing like a huge discrepancy between the speeds of light, your guys are claiming because it's the length the one of the lights had to travel is longer. Either way, they're either getting there at the same time or at different times. Um, how would you guys prove that the path is longer and it's not just one of the light beams going either counterclockwise or clockwise is accelerating?
Is accelerating? Why would it accelerate? What would cause that?
Well, that's what you guys haven't controlled for. You guys haven't actually tested. This isn't like an experiment you guys do. This is just let's see what happens, and whatever happens, we just say this what happens on the globe.
How did we test for that? That it doesn't just for no reason increase and decrease?
How do we test for it? Well, so like different, like within the other interferometer experiments I showed, water, a medium is affecting the acceleration of light.
The velocity, not the acceleration.
Velocity.
Yeah.
Sure. So if there's an etheric like medium, it could be pretty much spinning everything and causing a component that's accelerating light.
Yeah. Well, I mean if that's fine. We can test for that and then say, well, if that was the case, if there was a spinning vortex, then what would we expect to see in the measured results? And this is not what we would expect to see. In fact, if there was a spinning vortex where there's, like this is what a spinning vortex would look like. So you've got near the center, the velocity, the linear velocity is smaller than as you get farther out because it's got I guess we can presume that it would go around the same number of times in the same period of time. So let's say it goes around once a day. I don't know. Just use that for an example. Then near the perimeter, it's got to travel significantly farther in order to do that in a day than near the center. So if you take this interferometer here and then put it here, right? I'll just draw it as this diamond shape, right? What would you see? Or even more to the point, I'll draw it as a square because I think it'll do better. Right. So you're saying, all right, so this ether is vortexing and we send light in two directions around this square, right? What would we expect? Well, as the light travels this way and this way, up and down on these sides here, we would expect to see no change in the velocity of the light, right? We're hypothesizing ether and undulating theory of light here, right? So, right, it goes.
Wait, where'd you make no change? That looks pretty south.
What do you mean where I made no change?
You said that there's no change to the velocity of light. Where is that?
Yeah. So
below the equator.
If it doesn't matter north or south of the equator at all in the undulating idea. There's the vortex is just a big vortex around the whole thing, right? That's what you think it is. So unless I'm wrong, this is what I'm kind of gathering from your and from others that have had this same position. Right? So
I just don't know what you mean by so at the equator is where we don't measure velocity change.
Yeah, but I'm stepping through what we would expect based on a rotating vortex of ether and undulating theory of light being, this is what it would predict, right? So I'm not yet considering what we have observed. I'm just looking at what would this hypothesis predict. So
you're claiming it would predict no velocity change farthest south?
It doesn't matter where. So I'll draw the same box up here. The same box up here on the north-south paths, the ether vortex is moving orthogonal to it. So it's not going to change its path or its velocity, it's going to go these directions the same. So now here's where it's going to be different. When it's going these directions, it's going to be faster going with the ether and slower going against it on both of these. So right here, right here. So let's say that this is that it's relatively small. The box I drew is relatively large. But what's going to happen is, if they're the same amount of ether velocity, which we'll come back to that in a second because they wouldn't be the same ether velocity, but let's say that they are, just to simplify for the initial step, then the light going this direction will be increased when it goes here, same when it goes here, decreased when it goes here, and same when it goes here. So then,
where are you coming up with this, dude?
I'm just applying the undulating theory and the vortex.
There's no, this prediction doesn't even exist for like how this interferometry would work over a AE, flat Earth model.
No, that's
undulatory theory had nothing to do with flat Earth back then.
The undulatory theory had only to do with the propagation of light. So yeah, exactly. It was independent. It was essentially independent of the shape of the Earth. Just like if you're going to go and sell some sheep down at the sheep store, the sale price of the sheep is the same regardless of the shape of the Earth. So it doesn't matter what shape the Earth is when you're talking about the undulatory theory of light. Now I'm taking.
You're claiming.
But I'm taking.
Why you're claiming this.
Yeah, I'm just applying the undulatory theory of light to flat Earth with your claim of a ether vortex, right? Because I asked you what this was, and you didn't know, and that's fine. And so I'm just going through what this the consequences of this hypothesis are. So just I'm almost done. So if you just let me finish here. So I would expect in the simplified model that since this path is increased and this path is decreased, that they would net cancel each other. And so then you would not see a shift at all. And it doesn't matter. You'd get no shift here, no shift here. Now, the slightly more nuanced version is that the path or the velocity of the light here is slightly less than here. Slightly less because this has longer to go in a day and this has a shorter to go in a day. So this path,
you're like, I don't know, you can come up with this.
I'm almost done. So when the light goes, let's say it goes this direction and then this direction against this less flow, it's slower, but not quite as much slower. And then it keeps going and it goes this direction and it's faster, and it's faster by a bit. So this path is going to be a little slower and a little faster, right? And then you go the other direction, it's a little more slow down going this direction against the faster ether flow, no net change, and then faster going here. So then again, you're going to get no change, even if you consider that. There are ways to potentially consider that by maybe shrinking this or having a different geometry. I don't know. But I think unless you had some...
You're basically...
Oh, go ahead.
Well, you're just claiming a different... Just the direction of the ether spinning is just causing things going in that direction to speed up. Like it's not really... I mean... I'm not saying I know what's going on, but that's not my theory. And
okay,
it's not like this is working like, it's not like working like water where like it's just a simple river. It's just pulling everything in one direction. It's pretty much seems like it's doing the same thing as what's going on in like induction currents, where a coil is basically just ramping up the voltage within like a transformer. The coiling of the interferometer setup at different latitudes basically increase it speeds up light going counterclockwise while the ether vortex is going clockwise.
But that doesn't match though, because if the ether vortex is all going the same direction, then you wouldn't expect to see a variation in the direction of the measurement, and you wouldn't expect it to be zero at the equator.
There's no, it's never, it's just different levels of the Sagnac effect, but there's never I'm not sure which, do you know which light path is going faster within a ring laser gyro?
Within a ring laser gyro, all of the light is going the same speed, c.
Well, I mean, like, sorry, I meant which based on like the fringe pattern, like which light path was had the longer distance, I guess, within your model.
Well, it depends on the direction it's going, of course. So if it's like in the example here, if the light leaves the laser here and then it rotates counterclockwise, right? The path that the light has to take in the counterclockwise direction has increased, and the path that the light has to go in the clockwise direction has decreased.
Yeah, so clockwise. So the counterclockwise one, no matter where you are on Earth, is the one arriving sooner, right?
In the one that's arriving sooner is the one going in the clockwise direction.
Okay, whichever it is, it's always the same one that arrives either sooner or at the same time.
Depending on the direction, if you rotate it the other direction, the other path is going to arrive sooner.
If you rotate the ring laser gyro, that's what happens?
Yeah, if you rotate the ring laser gyro the other direction.
Oh, really?
Yeah.
That's interesting.
Yeah.
Yeah, I mean, I kind of want to get a ring laser gyro. It's kind of cool.
Yes, you should. You should get one. The one that Bob got was rather expensive, but you can get single axis laser gyros, ring laser gyros that are much cheaper.
So what I would want to do is like different, I don't have much like, funding, but like there's, so as far as all these things like being latitude dependent and being just like consistent, that's what you guys claim, but it doesn't seem like that's the case. And I'd love to like test for different anomalies within these consistencies you guys claim. Did so Alan and Shane, they did a presentation on a book called The Anisotropy of Space. Have you heard of that book, or did you see that presentation by any chance?
I have not seen the presentation.
Well, so I want to get the book, but obviously the book doesn't. I don't just trust books blindly. So it could, you never know. This guy could be, just because it says some data, it doesn't. It could be fake. I'm just hyper, conspiratorial. So I'm never sure if something really happened. But if within that book, this guy was basically doing tests with different Foucault pendulums. He had a Foucault pendulum that was called something else because of some addition he had for it. I'm not sure if that might be the reason why there was the different effects, but basically he claimed during eclipses the Foucault pendulum was having he was getting different results, like
that is it's called, it was a guy named Elias that claimed that he measured a different result from Foucault pendulum during eclipses, but it's been repeated by him even, and not been it's been tested again but never repeated. So he had a couple that he tested, thought there was something, was unable to repeat it. So repeatability is a key part of science, of course. So when you do something and you've discovered you can't repeat it, then there's something else that's likely that was going on. Could have been an error in the measurement, could have been, you know, any number of different things that cause that. So
Maybe that was a different guy, because within, at least from the part of the book I heard Alan read, he said it said that the guy basically retired, like he just gave up on it. So I don't think he ever, like the guy from this book didn't ever try to repeat the test.
that sounds like Elias.
I'm not sure.
Yeah. He tried and tried, like he thought he had something. He thought he was going to make the big breakthrough. And, you know, in science, if you do make the big breakthrough, you get the prize. You get that big Swedish prize if you're the one that gets the big breakthrough. So a lot of people do that. They find something, they're like, I'm certain this is it. I just need to tweak the right knob. And some of them dedicate the rest of their life to it, and to just, you know, to have been thrown off by an anomaly. So was that it? It seems that was it with Elias, if that's the same guy you're thinking of. But maybe there was something and more research could be done. Could be. Different people have all tried many times to falsify Einstein. Because if you do falsify Einstein, if you falsify general relativity, you get the big Swedish prize. There's no higher prize in science than that. So if you can show that some current, you know, well-established and accepted part of science is wrong, go for it. The door's open. But, you know, it's not easy to do. You have to do better than the current model.
Maybe I should look up really quick who the guy. Let's see. Let me check if this is the same guy. Because yeah, I chat GPT'd about this, and it's bringing up the Elias guy that you said.
Yeah. Okay. Well, while you do that, all right. If everybody can just give me a quick in the chat hashtag OWRS, I'd appreciate that. Just do that real quick. No reason. Just trust me, bro. There we go. Let's see. Basil Problem for his $5 super chat for the night. Next is 10. He asks, are you the shark or the remora? I am the shark. Real Harnold says, ask KeeKoPip how he typed that M dash there. We got the answer to that. We did. Dolly8825 says, I don't have a gift sub button, so here's some cash instead. Keep making Flerfs cry. Thank you so much. I appreciate that, Dolly. Brenda says, is this a 10-hour soothing rain with Flerf stream? It's not. He is there's no more rain sound. Did it stop raining there? No? Okay. Maybe we'll find out in a minute.
It's not raining as much. So yeah, so this guy Elias is the one that wrote the book that I was quoting from Alan's Prezzie.
Okay.
So as far as what ChatGPT says, it says that reported changes included a sudden change in the rate of precession, total deviation of about 13.5 degrees during the 1954 eclipse. The anomaly lasted roughly the duration of the eclipse. Replication attempts, results have been inconsistent. However, torsion pendulum, several. It doesn't say that he himself tried to do it again. So there is something about his pendulum that was, I forget what it was called, but I don't know if they definitely don't make that. They don't use that kind of pendulum for nowadays for any of the Foucault. It's not a Foucault pendulum.
I'm sorry to interrupt, but may I make a brief point?
Oh, that's to you, Q-Up. Tony, I don't know. He's not answering.
Yeah, I'm just trying to see what
Okay.
it's called. So it's called a paraconical pendulum. It differs from a classic Foucault pendulum because it is suspended, so it can swing freely in any direction. A blob is periodically restarted rather than left swinging. Yeah, it doesn't sound that much different, actually.
can we go back to the Sagnac effect? Because it sounds from what KeeKoPip is saying that he thinks that the Sagnac effect only shows up in laser gyroscopes, and that's just not true.
Okay, well, enlighten me. That sounds interesting.
So there are things called matter wave gyroscopes where we
What did you say?
propagate.
You're kind of coming in weird for me. What'd you say?
There are things called matter wave gyroscopes. They use supercooled clouds of atoms that all share a common wave function. This is called the Bose-Einstein condensate. You propagate them around the circuit, and then you recombine their wave functions at the end, and you can see a Sagnac effect in the recombined wave functions. So if your claim about the Sagnac effect is based solely on something that only affects light, then your explanation is wrong, because we see the Sagnac effect in the propagation of quantum objects.
That's cool. I'd like to research what kind of instrument you're talking about. Obviously, as far as all the physics you claimed, I don't believe any of them exist in reality in any level.
So
I'm sure.
it's a big
started.
bucket of nah.
I let you go.
And,
I'm not saying no. It's very long. That's why I need more time, because it's not just no.
It is. You just don't believe the physics. Okay, then what?
Do you mind?
I just thought I would.
And then you can go after I talk. This is my server.
All right, go ahead then, KeeKoPip.
So yeah, so I don't believe any of the physics he's talking about. So as far as I'll research. What'd you say, matter? So I'll research it to see what it seems like the instrument's actually doing, because usually like they'll claim a bunch of quantum physics stuff and it'll just be like an electromagnetic instrument.
There you go. It's
what was it called? Matter what?
Matter wave.
Matter wave. Yes, MATTER -wave gyroscope.
Is that hyphen? Is that an M dash or an N dash? Arnold wants to know.
I don't feel qualified to answer. So,
you know, the humility of somebody that doesn't have the background in typography, not declaring the answer of the typographical answer. You know, PhD Tony does not want to be accused of being a member of the Dunning-Kruger Club. I appreciate that.
That's right. Yeah. Sorry. Carry on, Tim.
All right. I would say it's an N dash, and sign language N. There you go.
So it's pretty. So it seems like I'm like researching it really quick with ChatGPT. So first it said what he said, which is, it sends atoms around. Then I try to figure out what kind of element and what state these are in, and then now it says it's pretty much just a soft solid metal.
No, it's not. It's a cloud of supercooled strontium atoms is generally what we use. I think there's, what's the other
gas?
one? It's not a gas, it's a Bose-Einstein condensate.
It's a different phase, type of matter.
That's a different phase. It's a different phase of material because it behaves very differently. You get a cloud of atoms, cloud of individual atoms, you supercool them down, and once their velocities are low enough, they begin to share their wave function. So they all propagate. So you can construct a large cloud of atoms that propagates as though it's a single quantum object.
All right, so I mean, I doubled down and I asked ChatGPT. So this is a gas basically traveling around a gyroscope, and it said yes. It's a very dilute gas. Dude, oh my god.
ChatGPT is trying to give you a simple answer.
Bro, I can't mute you. I can only kick you or ban you. So can you just shut up?
Well, if you're going to,
I can't mute you, so I don't want to have to kick you, dude. We can talk.
Okay, but you asked me a question and now you're trying.
Okay, well, I told him that's my only option, to either kick him or he fucking just waits to let me talk. So I guess he wanted me to kick him.
Well, he was trying to explain, I think, that ChatGPT isn't necessarily the way to go here. Because
I agree.
I don't suspect that you consider ChatGPT to be an authoritative source for answers, do you?
Well, I'm just there's a quick search. It just gives me the most information, the quickest. So it says, ChatGPT is saying it's in this matter wave gyroscope, it's a very dilute gas of neutral atoms, it says, but it seems like it's just a gas moving around a gyroscope. So all the claims about, what this is and how this relates to quantum physics, blah, blah. That's just kind of theories.
He was, I think he was addressing when you were talking about whether or not we've done it with light. This is with something other than light.
Yeah. So one of these highly metallic gases, I guess you could call it, is just traveling faster in each direction. So it's pretty much like an interferometer.
It's not a gas, but it's sort of like a gas. It's probably, I think you could call it a fluid, but water is a fluid, gas is fluid, plasma is fluid, Bose-Einstein condensates are fluid. Right. You could also say that plasma is a gas, but it's not actually a gas. It's plasma. It's a different state of matter. So Bose-Einstein condensate, again, it's got properties of gases, but it's not a gas. It's a Bose-Einstein concentrate.
Right. I mean, whatever it is, it being affected the same way light is and pendulums, like it's just latitude dependent, and there's something we're observing to be happening, and it changes based on latitude and possibly during eclipses and all this stuff. So it's none of it is like exclusive to the globe model. It's just the globe model, kind of, claims this is exactly the amount that these things are going to be affected at different locations, which has changed after observing them, right? During Michelson-Morley, their prediction for the amount was wrong for the globe model, and now it changed to what the result is, and now the result becomes what the globe model predicts, which is just ad hoc. It's just post-diction.
I don't think so, but okay. All right. Well, that's I don't know. That's interesting. Some other people are in the server here, and I think Cody Payne has asked if he could come in. Cody, you're welcome to join the Discord server and pop in. Anybody else in the Discord server have anything to say? While you do that, I'm going to read this here just a second.
Except for Perfect Storm, you can't talk.
From Zoomicide says, so there's a restaurant called Oatmeal Cafe. Does that mean if you get pregnant in the bathroom, your baby is an oatmeal cream pie? Very naughty. You're not allowed to laugh at that, people. 3 Ron says, that moron needs to shut up when Tony speaks. Well, I think that's, you've made a good point there, 3 Ron. All right, where did this go? Let's see here. It didn't capture the one from Stringfellow Hawk that says he's doing research using ChatGPT. Ask him to type into ChatGPT, what is the shape of the Earth? There you go. Ask him that.
Well, I mean, so obviously ChatGPT can't know what the shape of the Earth is, so it's just looking up how this gyroscope works and, blah, blah, blah. So I'm just trying to figure out what I don't think they can't lie about what's going on, like what is happening in an instrument. That's why you guys claim, that's why they, we don't feel the Earth moving, but, within instruments, they claim that this is proof that Earth is moving, but, so the instrument itself is not, there's nothing they can lie about,
Yeah. Funny here. Dude asks, so what can you do with flat Earth science? And Locksmith says, all aeronautics and any experiment conducted in the lab frame is the answer as to what you can do with flat Earth science. So all aeronautics. Does that mean, I would assume that means navigation, but I've never seen anybody do navigation using flat Earth. That's funny. Locksmith, unfortunately, isn't in the voice chat here to provide an answer for what part of aeronautics uses flat Earth. Do you know what he might mean, Q up?
I wasn't paying attention, but he's in the Discord server, so you can pop in.
Yeah. Let's see. I'll ask him. In flat Earth aeronautics, do navigation. There we go. Sig says misunderstanding engineering idealizations like it's 2017. Absolutely. Okay. Let's see. Third Duras sister is here. I'm just trying to get a couple of people to talk here. Oh, Buck.
Well,
Buck
I do
Sodbuster's
have a
here.
question. Can you hear me?
I can hear you.
So it sounded like earlier that you were saying that the Foucault pendulum would work the same on a flat Earth. How is that? Like, would I be able to tell my latitude on a flat Earth with a Foucault pendulum? Because I've never heard an explanation for that, if that's what you're saying.
So different flat earthers have different theories and stuff. So for me, basically, I think if let's just imagine, right, there's a vortex over the earth, a giant tornado of like a giant electromagnetic tornado. And the vortex, the smallest part, the tornado part, is over the North Pole. It's wide enough to go across all the way to Antarctica and beyond. At different, and basically, just like in a tornado, different parts of the tornado are going to be affected differently, right? So if you're at the center of the tornado, we all watched Twister. They, whether or not that's true, let's assume, at one part of the tornado, there's a different effect than other parts. It seems like this etheric tornado, has different effect at the equator. Pretty much the effects all kind of just completely die off completely. So based on that, if you figure out how the continents are in relation to this vortex, you can use things that basically pick up the different effects of the tornado to figure out where you are in the map, because the tornado has different effects at different locations.
So like in the middle, it would have less, and as you get farther out, it would have more velocity?
Well, that would be if it was just a real tornado. This is not a tornado wind. This is a tornado of electromagnetic forces causing anomalies at different parts.
Well, I did go over that already. And
yeah, so that's what I was saying. So if it was like you're treating it like it's just like a basic river, like a tornado, like a wind tornado. So that's why.
No, I was treating it as an ether tornado.
But you're still treating it like a normal tornado. So like this is pretty much like just like a, it's not causing wind to move. It's charging things differently at different areas, but it's vortexual only in the sense that it's spinning. It's not like
Is there
not a tornado.
Is there no dirt in the middle?
What?
Some people have said there's no dirt in the middle. I don't know. Maybe there is dirt in the middle. I don't know. All right. Wicked Pissa started sharing a screen. Was there more comment, or was that a mistake? Don't know. No, nothing. Buck Sidebuster, come here. Let's hear it. Let's hear what you got to say, Buck.
I haven't been listening. I don't even know.
That's okay. You didn't miss anything. What's going on?
Not much. Just returned from a public dance with my wife.
A public dance. So you were dancing where people could see you dance?
Let me tell you, my wife is like a natural salsa dancer, and I am the exact opposite. I'm the most unnatural salsa dancer. No matter how many lessons I take, no matter who tries to explain it to me, it just does not work. And it's embarrassing and humiliating. But I do it because I love my wife.
I feel pretty similar. I love to go dancing as long as it's foam dancing. That's where the dance floor is.
What?
Foam dancing.
Oh, so they can't see you.
Yeah, the whole dance floor is covered with foam falling from the ceiling, and yeah, I just get into the part where it's up to my shoulders, and then I'm just a head bobbing around, and nobody knows how dumb I look. So there you go.
That's a great idea.
There you go.
Suggest it to her.
Yep. Then she can be out of the foam, and you can be in the foam. Bring a change of clothing because you'll get saturated.
Okay, I'm gonna suggest that to her. Thank you.
Wait, are you talking about like a foam, like where they like pour foam on everybody in the dance floor?
Yes.
So I was at there's like this there was this DJ there was a venue owner in Connecticut. I don't know, he got pretty famous, but his name was like Ian Bick, and he had this club named Tuxedo Junction, and he basically was running a Ponzi scheme, and he was just, a Ponzi scheme is like you get a lot of investors, you throw a party, you can't pay back the investors, so you get other investors next time to throw a party again, and you just keep owing more and more people if you do it right.
So that's what we are all happy now that we know what a Ponzi scheme is. Okay, let's go.
Well, it's just interesting because I was basically friends with him, and I was basically allowed, like I was basically VIP in all the shows. He had like Steve Aoki and all these people. But like one night, so he got like arrested for that, and he went to jail. That's why I just thought maybe someone knows. It's kind of interesting. But he had like a foam party one night, and they were throwing so much foam on everybody. I started selling Ziploc bags for like $3-5 each, just so people could like save their cell phones. It's pretty funny.
Okay.
Hey, so my wife is here now. Do you want me to explain your suggestion to her?
Yes.
Okay, Mrs. Sodbuster. I explained how you're a really good dancer and I'm a really bad dancer. Oh, these are my like flat earth and anti-flat earth friends. They had a brilliant idea. Since you're a great dancer and I'm a horrible dancer, we need to go to one of those dances where it's all foam. And then I can be, like, those spring break dances and stuff where, so I could hide in the foam and no one would see me, and you could be outside the foam and dance away. She just shook her head.
She said no?
And she shook her head in I don't know.
Yeah, you've done wrong.
Find those foam dances.
Yes, you're correct. There was one in Minneapolis on the way north side. It was a hike to get there. But years ago, my wife and my friends and I, we all went, made an event of it, stayed till bar close in next to Maplewood Mall. Just drove forever, but we brought clothes to change. But at 2 a.m., you're gonna be hard to believe. But there's no bathrooms to be found at 2 a.m. So we had to find a place outside the mall where there were some pine trees that had a little bit of cover to go change. There you go.
Here's the problem she has. Her understanding of flat earth and all the people involved are two people. The first one is Arwen. She thinks,
oh my gosh,
you all are represented by Arwen.
Okay.
But then she met in person Harnold.
Yes.
And he's a normal guy. So
okay.
Her perception of all of you people is Arwen or Harnold.
That's fair. That's a very fair. Yep. 100%. All Flerfs are Arwen.
Not fair.
What? You don't?
Not fair.
What is Arwen cooler than you?
I think we should. I think the contestants should be me for flat earther, like a general, like what a flat earther is, like super cool, like really deep and,
But if
and
she saw,
interesting.
if
And
she
then the
saw you, she would
Glober
fall
would
in
be
love
someone
with
like
you.
Max, who sounds whiny.
But Buck,
If she saw you, she would fall in love with you and want to leave me for you, QUp.
yeah. Don't tell her that he does not have sleeves. That would be disastrous for you, Buck. Unless you want to go and live the no sleeve life. But I don't know if you're ready for that kind of lifestyle. I mean, that's commitment.
It can get pretty breezy.
Yeah.
Well, thank you guys all for your advice.
You'll definitely be able to measure a globe Earth Coriolis without your sleeves on.
Arnold just posted a very nice nice of you riding a dinosaur, KeeKoPip. The KeeKoPip and the etheric tornado. Oh my gosh. You like it, Keeko?
What is it in addition to that?
It's
AI
in
pick on with me on a dinosaur, but
it's
with
in
a tornado now?
It's in the chat, yeah. It's on your server. You I thought you'd like it. It's pretty good.
That's pretty sick, dude.
It is. You're riding a dinosaur.
Wait, why is my face so stupid? Who the fuck is that guy? That's not me.
That's you sleeping. Because you're always sleeping.
I'm not. Why am I always sleeping?
I don't know why. That's a question we should ask you, not you should ask us.
Yeah, I don't believe in dinosaurs, so it's a straw man. And I'm not tired. I wouldn't be tired riding a dinosaur. It makes no sense. I'd be extremely energetic. It'd be exhilarating.
You tamed a wild T-Rex. That is something not a lot of people have done. Oh man. All right. Well, so let's get some feedback from the audience here. What do you think, audience? Tag me if you want. What did you think of his presentation and how well it? Now this was going to be presented on Modern Day Debate where he was representing flat Earth, and so this was supposed to somehow present the case for the Earth being flat. So anybody, just go ahead. Just there you go. Of course, he doesn't believe in dinos.
Well, I would say it's nothing we haven't heard before from Woodford. Any of the claims is pretty much the same. So it's we're pretty much back to where we started.
I agree. Kinetic EV wants me to ask you about how all of the elevation angles to Polaris or to the sun on the equinox, or the sun on the equinox, totally destroys flat Earth. So what about that, where the geometry works for the globe and it does not work for flat Earth?
I have to make her argument?
No, the fact is that the measured angles to the sun on the equinox and the measured angles to Polaris all work for flat Earth, and they do not work for, all work for the globe and do not work for flat Earth. So why is that?
Why would they not work for the flat Earth?
That's the question to you then. Why do they not work for flat Earth?
You're claiming they're... Wait, what? I didn't... What? You're asking me to make her argument again?
No. Here, I can draw it for you. Here, I'll
said
show you.
Why? You're asking me why it doesn't work on flat Earth? I think it works on flat Earth. So why are you asking me to help you prove why it's an exclusive proof of globe Earth?
I'll show you. All right, can you see me sharing my screen there?
Yeah.
All right. So here we have, is that green? Okay, this is the ground, right? And then I'm gonna put, this is for flat Earth, right? So people need to know I have to label it.
Demonstrated by the flat line.
Yeah. So now at where I live, I'm right at 45 degrees north. Latitude, we'll put that right here. Right, so at 45 degrees north latitude, let's see here, I'm going to measure this to be 10 centimeters. So right
I'm about to
here.
start making Nathan Oakley arguments right now.
Well, I mean, this is what Nathan Oakley claims. He's said it many times. So all right, so here's Polaris. Right, and so the elevation angle to Polaris at 45 degrees north is 45 degrees. So there you go. Now, if we go to so at the equator, and I'm not going to go to the equator, I'm going to go to halfway between. So, but here we're going to draw the equator at 20 centimeters, and then right here at 45, or at 15. So this is right here. We've got, what color? Is this red? That's red, I think. The red and black are very similar to me. Okay, so now, what is the measured angle to Polaris at 30 degrees? Sorry, that's not supposed to be 30. That's supposed to be 22 and a half. Okay. What is the actual measured angle to Polaris at 22 and a half degrees north latitude? 22 and a half degrees. To nobody's surprise. So I will draw that. And so this is now testing the flat Earth claim. So I just need to put this down here at 22 and a half degrees. Right there. I'll put a little dot here. And then I'll draw the line. So this is the common position of flat earthers, is that this works, but they've never, to my knowledge, they never tested. So this is the angle that is actually measured in reality. So we've now got two positions, two angles, just two. This is all the farther we got before we ran into trouble. This angle right here is 22.5 degrees. So, but there's, how many Polarises are there? There's just one Polaris. Unless flat earthers claim there's infinite Polarises, which would just be funny. So when you're at 45 degrees north latitude, this is the physical location of Polaris. When you're at 22 and a half degrees north latitude, this is the physical position of Polaris. This doesn't work on flat Earth. This line here varies constantly no matter where you are by latitude. So the geometry doesn't work for flat Earth. So
I agree if you're claiming that's the real position of that body.
Yeah. So when I say it does not work for flat Earth, this is what I mean. And so then the question then becomes to flat earthers, right? This is the map that this is based on. And you read the little instructions here. There's 1 degree per 60 nautical miles latitude. That's what I did. So, and flat earthers claim that Polaris is somewhere up here above the North Pole, right? Every day on all over the place, this is claimed. And it's not just Facebook, and it's not just YouTube videos. It's all the books that the flat earthers have published. These books, right? All these books make the same claims, right? Look at that. See that? That's one. This is The Sea Earth Globe by Zetes. We've got Fred R. H. Cook's book, The Terrestrial Plane. I don't know if I bookmarked it, but this one makes similar claims. Let's see. Sometimes they have diagrams. Sometimes they don't. I don't know if this one does offhand. Maybe not this one. Zetetic cosmogony. Look at that. It has it right there. This is that same claim. They use 45 degrees north latitude, in fact. We've got a Carpenter's claim. He's not good on diagrams, but this is what Eric Dubay used and then doubled by basically repeating a lot of the same ones for his 200 proofs. So you've got Zetetic Astronomy by Lady Blunt and Albert Smith. Again, similar claims. So these claims about the physical position of the sun and stars are similar in all of these books right here. Here you go, sun, stars, right? So then the question is, where, if that's not correct, the question then to all flat earthers is, can you explain it? If this is wrong, then what's right?
Well, what's wrong is treating everything optical as it should be, like, Euclidean position, straight line of sight to the source, and that's not what I claim. So
Okay, well, what is your claim then, very specifically?
the same thing that causes bottom-up obstruction, the sun setting, and the stars being lower than they should be on an AE model optically is the same, refraction effect. It's just perspective and some refraction.
Refraction
causing things to be lower than they should be.
So refraction caused this dramatic change in elevation from 22.5 to whatever it would need to be to match reality. We can measure that right now.
It's called an angle of elevation, an elevation angle, but it's not real elevation. It's just, to a certain extent, you can take angles of elevation and figure out elevation of things nearby, but
so you're claiming something is causing it.
We can't validate
something is causing it.
So.
Well, we can measure. So here is the, I'll put it right on the spot there. And so the measured angle there is 34 degrees. So I measure 34 degrees. So the difference between 34 degrees and 22.5 degrees is caused by refraction.
What were the 2 degrees?
22.5 and 34 is the difference there. So more than 10 degrees variation due to refraction. And so then I ask, well, what conditions would cause that kind of refraction?
The same conditions cause refraction. It's just, light going towards a denser medium. So you guys are claiming that outside the atmosphere there's like a vacuum of space and there's no density. And if that's not the case, and they're faking going to space and there's no space and there's extremely dense medium above us, then there's just more mediums that you guys aren't accounting for causing refraction.
Okay, and how was this empirically verified?
I didn't claim to go to space. I'm just saying that's a possibility. And then you guys are claiming to go to space, and that's not a possibility because you guys proven it. But you guys have gone. It's only Freemasons that have gone to space.
Well, it's not only Freemasons that have gone to space. Charlie Duke's not a Freemason.
And Katy Perry.
Charlie Duke is not a Freemason. He went to space. It's not just Freemasons. So, that's just something that flat earthers have said, but never substantiated. And
so I agree, it's possible that some aren't, literal Freemasons, but it's just like a quick way to say that they're all,
Yeah. So let's do this. So, we've sent up rockets, and we can see with our own eyes. Reds Rhetoric has done it with his own eyes, and his cameras, and he's recorded it where he's seen the plume from rockets get wider and wider as it goes up and up. And that's because the pressure, the air pressure goes down. And we see that too. You drive up a mountain, you get lower pressure at the top. You take go in an airplane, there's less pressure outside the airplane. So we know that continues, the pressure decreases. And you're saying, well, maybe at some point it starts to increase, but when has that happened? We've never seen that. So definitely in the bottom, 100 kilometers of the atmosphere, the pressure continues to decrease to a near vacuum at 100 kilometers up. So we've got this gradient going the other direction, where the denser medium is close to the ground. That's what we don't see anywhere in observation, where it gets to be a denser medium as you go up high. So what we should see is the light bending toward the denser medium. So I'll make a little density like simulation here, right? Not a simulation, but each line, see, the lines are meant to show increasing density. So we've got more density down low, right? So that means that light should bend. So if I take a beam of light, make it orange, if we start it here, then it will go down as it moves along, because it's denser farther down, right? So then if you have a person here that normally would have seen this ray of light, they're not going to see it, because that particular ray of light is going to hit the ground before it gets there. So the ray of light they're going to see is the ray of light that started up higher and then got to their eye. So the angle that they see the light coming into them is going to appear higher, not lower, higher than it is without refraction. So in order for this to happen, for the light to start here and then get to the observer at a lower angle, the light's going to have to bend down, bend up. So what's going to happen is the light would start this way, and then it's going to be bending away from the ground, and then eventually come in at 22.5 degrees. So this path of light is bending up. In reality, light will bend down based on observations. So you need to have some empirical evidence for something causing light to bend the opposite direction from how we know it bends.
Yeah, I wouldn't agree with this being like this is not a realistic I mean, you're covering some things, but I think you're missing some things, and also the fact that so as far as that first part over there, but that one light path is basically crashing into the ground, so that person is not seeing that light, right? Because it's hitting the ground before it gets to their eyes.
Yeah, the light that would have gotten to the observer if there was no refraction hits the ground, but the light that where the ray was angled up a little bit from the other one, that's the light that gets to the observer, and that's why the observer sees it at a slightly higher angle than where it would be viewed if there was no refraction. So I mean, both
of those paths look like their refraction is causing them to bend downwards. I'm not sure why you mean one's no refraction. Both of these light paths are bending down due to refraction. This isn't the light path. This is the angle that the observer sees the object at, right? So the observer would, this is very exaggerated, but they would see the light or the object up here in this, very exaggerated, right? That's where it would look like to them. It would appear higher than it is in reality, right? But that's not what's happening here. This is the opposite. It's appearing. You're saying Polaris has to appear lower, and so now the light has to bend the other direction. But we don't. There's no cause for that. Yeah, but you're still taking, I don't know if I agree with you on how the light will be visible based on the angles that the refraction is causing the light to turn. But as far as the main thing you're missing is just perspective that causes things to drop on just because of perspective. So
I computed that. That's exactly what I did. I already did the perspective. This is awesome. So right here, you see this angle here, 45 degrees. And then according to perspective, if you're looking at the same object and there's no, if there's no refraction or nominal refraction, then at this position, perspective requires that the elevation be 34 degrees. That's what this is. This is perspective.
Well, that blue line isn't a 34-degree line, or is it?
Yeah, it's 34 degrees. I measured it with the angelometer here. I keep my angelometers close. You know.
It seems like the point of Polaris in this thing is the same no matter where you are.
I'm just showing. I mean, this just shows that the angle to Polaris does not match flat Earth. Also, I met a guy at the observatory who worked at the observatory in Saskatoon who collects calculators. So there you go. In case you anybody wants to see my calculator here. And yes, I don't have to. What?
Can you do something for me? Can you write boobies with the numbers and then flip the calculator up?
I was working on it.
That's all I did.
Yeah,
with calculators.
8008135. But I can do even better than that. I can do better than that because. Can
you write 304?
I can just do it with letters.
This is amazing technology with letters now.
There you go. I can just do it with letters because this has an entire character set in here I can use. I can even do lowercase if you want. But can it run Doom? It cannot run Doom as far as I know. So there you go. And I could put it upside down, but it doesn't matter because I just wrote it right side up. There we go. That's my, I got another one. Hold on. This is my 48SX. So this is the G, not the GX, the G. This is the SX, but this one broke eventually. This is the one I had at college. And it has, look at this, it has a memory card in it. Look at that. It's a 128K of RAM memory card, which is coincidentally which Apple computer shipped with this? Which Apple II? Anybody in the comments? With 128K of RAM. Initially, not with upgrade card. Initially. Does anybody answer? Anyway, I used to have a second card in here that would model electronic circuits, but I sold it to somebody when I was in college because I decided I'm not going to do electrical engineering. I'm going to write software. So, in fact, this has a full programming language on it, QOP. I know you're wondering, does it? In fact, it does. It's called RPL, Reverse Polish Language. And I would sit in the boring classes and write programs on this. There you go. Algorithm, nope. Decala Badger, nope. 3-Ron, nope. Extra J, the Apple II GS probably had more than 128. To my knowledge, the Apple IIe initially shipped with only 64. And you could upgrade it. But the first Apple II computer that shipped with 128 is, in fact, to my knowledge, according to Small Duck, 1001001, the 2C, that's right. The 2C. Now, I could be wrong. I'm going off of memory on whether or not the 2E had its stock from day one. But anyway, there you go. Queue up. Can we see your calculator?
I'm like Matt Damon in that movie where he figures out things in his head and just writes them on the chalkboard.
I don't believe you. I don't believe you at all. I don't think you can do math at all. You've said that before. You said you can't do math.
It's not that I can't. I just don't. I just chose not to because it's for computers, right? To compute things has nothing to do with like figuring out anything like about reality. It's just math, like it's like a component, but it's not. It's like, what is my height? I know I'm taller than most people. I don't need to know exactly. I don't need to measure myself or figure out the number. Like, it doesn't really matter.
Yeah, I think you struggled with it. That's okay. People don't have to be good at everything.
No, I didn't struggle. It just bored me to death. I didn't. As soon as I was like a freshman in high school, I was like, okay. Once I got to algebra, I was like, I'm not paying attention. I'm not. I just literally didn't even go to math. Like, it's nonsensical, honestly. Who uses algebra, dude?
I do. Even though I write email filtering software, it's not math heavy. It is. There's enough math in it that I definitely do use algebra.
Coincidentally, all the things that I think I needed to know, I ended up not needing to know. So.
I don't know. Maybe it would have done good for you to learn a little math. You could have been the Neo, the Flat Earth Neo, right? All right, where'd it go? I had to reboot this app. This app seems to have stopped working. So let me see here. There we go. I got some of these back. Stringfella Hawk says for $10, he's doing research using ChatGPT. Ask him to type into ChatGPT, what is the shape of the Earth? I always ask him that. Like, if you don't think that ChatGPT is an authority, then I wouldn't be mentioning that you're using it for research. It's a good way to find things and then go read the actual information. But the answers from it are no more authoritative on any topic than you'll take for topics you disagree with. Cherry picking is not how to do it. Alyssum says, might have asked this before, but why do we have to navigate based on the globe? Why can the flat Earth not be used for navigation, not even distance? I think that's to you, KeeKoPip. Do you know?
Is it another person again asking me to make her argument for her?
No, this is Alyssum. Alyssum saying all navigation uses a globe and no navigation works with flat Earth. And so wondering why does no navigation work with flat Earth?
But she doesn't know that. She's just saying that.
It's a guy. But no, we've tested.
Yeah, well, no,
we've tested.
No one navigates with a globe.
In fact, all navigation uses the globe.
0 people use a globe to navigate.
That is
when they look with the
incorrect.
The air towers, traffic control doesn't use a globe. The plane doesn't have any instruments that have a globe. When you use your GPS, there's no globe. The only time there's a globe.
That's incorrect.
Zoom out all the way. When you zoom out all the way on Google Earth, sure, it turns it into a globe, but you don't use that to navigate.
You certainly do. You don't use a physical globe. No, you use the math, right? When you're doing when you're computing the distance between cities so that you know how much fuel to load in your plane, you use the globe. To do that, you need to know your starting location, your ending location, and then you do some globe trigonometry to determine the distance. And then you know how much fuel to put in. Now, if you used flat Earth trigonometry to do it, you'll get a different answer. And if you load in the amount of fuel that the flat Earth says, you'll have problems because you won't be able to land without dumping fuel.
The flat Earth doesn't talk.
What do you mean flat Earth doesn't talk?
It's if flat Earth says, as if like
flat
Earth gave you it's
math. You don't need to play word games, KeeKoPip. You're better than that. You know what I mean. We take the flat Earth claim. We take the flat Earth claim and we apply the claims of flat Earth, and we do the computation based on that, and we get the wrong answers.
All right, so I'm gonna take it easy for the rest of the night. My assistant, Seer Soul, is gonna take over for the rest of this debate.
Awesome.
He's very qualified.
All right. Tag off. That's good.
Read all the extremely hateful super chats and just ask Seer Soul to respond to them, and let's pretend that they're addressing it.
I don't have any hateful ones. I'm sorry. Okay. Well, thank KeeKoPip. Always good to talk to you. Thanks a lot, and we'll catch you next time. All right.
All right.
All right. PJ N dash KJ4MS says, I hope I'm just in time for all the Flerf evidence. You have in fact seen all of it. Yeah, you didn't miss any. Coincidentally, there wasn't any. DJ D1 Stewart says, Flerf say perspective changes angle of elevation. Perspective is the angle. Exactly. It doesn't modify angle. When you have the angle, that is perspective. Yes, exactly. PJ then sent 5 memberships. Thank you so much for that. If you are the recipient, then be sure to give a big thank you to PJ. NA for bacon. So spoiler alert, we live on a globe. True. Don't tell Q up though. It's fun to listen to his stuff here sometimes. Alyssum says, Q up, try not to BS a pilot on navigation. Exactly. And then NA comes in with 10 memberships. Thank you so much for that, NA. All right, Seer Soul, are you there? Are you actually there? Are you actually gonna talk? I guess not.
He just DM'd me. He said you're too low level of a glober for him.
He'll only deal with the higher level ones. I mean, maybe I can get some of the higher level ones. Who are the higher level ones that he would debate? Just let me know and I'll make it happen. Maybe.
He says he wants Neil deGrasse.
So Seer Soul, who's an absolute nobody, wants to debate the most well-known science communicator.
Your soul is very famous within the flat Earth.
Really? I love the sarcasm.
I'm not being sarcastic.
Yeah. Okay. Well, that's it. We're good then. I think we're good. This was fun.
Can I read some super chats from my audience? They said, yes. All these globers just make circular arguments and baseless assertions. What a bunch of losers. Oh, okay. Thanks for that super chat.
Who sent the super chat?
Seer Soul.
Oh, super kind. Thank you, Seer Soul. You're the best. Never heard of him before. All right. Well, I'm gonna wrap it up too. It's been 2 hours, and Seer Soul is apparently I'm beneath Seer Soul. The amazing
undefeated.
Yeah. Hey. Yeah.
Sorry. I was AFK. I just came back to hearing my name repeated.
Oh, I think Q Up may have made up some stories about you, having said that you would only debate Neil deGrasse Tyson and not somebody as lowly as me.
Oh, obviously that is a completely true statement.
Yes.
Could be found anywhere online.
Well, somebody's asking, who are the worst flat earthers to queue up? But maybe you can answer if he's.
Oh, that Freemason trash. Do you know that group?
No. Rusted Soul and Q-Op are kindred spirits. That's all I can say.
They are. They've got something going on. You know what I'm saying?
She's a lesbian.
You can fix her.
Bro, I couldn't. No.
What? She's going to get one look at your sleeveless arms, be like, oh, here we go.
Women.
Well, maybe it's because you've got such womanly arms.
That's very sexist. I thought you were a lefty. You're not supposed to claim there's any gender differences.
Oh, there's absolutely differences. I mean, you look at a dude, you're like, oh, that's a dude. You look at a girl, you're like, oh, that's female. Right.
Wow, dude, your audience is probably very angry right now.
We all can identify it. But if somebody was like, hey, call me this, I'm like, you know what? I'll call you that. So, all right. Oh, Zoomeray dropped a photo in Discord, but not. Must have been to my Discord server. I don't know where you sent it. I'm not seeing it as a DM to me. So, how am I supposed to find that? I don't know. If you want to drop a photo, the best place is to drop it into QOp's server, which is right here. So, all right. And it says MCToon. Do they know you've been to Antarctica near the South Pole? Yes. Yeah, he knows that.
Can you prove it?
Yeah, I have. I have.
I had to give you a softball one. Come on.
Yeah. I don't know. I mean, there's like, I was on the ground there for 3 days and some extra, about 3 days. I don't know. I had, except when I was sleeping or in the mess hall, I had the camera going almost the whole time. So many hours of video of not a whole lot of stuff going on, plus a few interesting things here and there.
Hey, Mike, it's Zoomerate. Can you hear me?
Yes.
Sorry, I'm not familiar with Discord, and I'm using it on iPad, which is just real messed up. But I dropped it in that link, but it's in a comment, and it's a photo that I've just dropped in the comment, so it's probably on your server. I don't know how to get it to queue up, though.
It's not.
So I've hit the comment button, and I've dropped it in there.
Comment on
1307.
On 1390. At what time?
At, 7 minutes past. I don't know what time you've got over there, but it was 10 minutes ago.
I do not see it here.
And I can only see a few comments. One from Third Dress Sister, one from Sig, and that's about it. So I'm probably on the wrong section, but
yeah,
I'm trying to show a photo from our system where QOP said that we don't use the globe, and I'm an air traffic controller. We 100% do, and I'd love to show him how and why it works.
Oh shit! Globe Earth proven. You have a globe toy simulation of a globe.
So
QOP, shut down the server, delete it. You're done.
Yep.
You're cooked.
Yep. I'm switching to globe like Jaren.
Here, I will. I'll send you a DM. And then you can get that. You should be able to respond back with to the DM there, and I'll grab it.
Yeah, apologies if I'm going to
see that. It's okay.
Messed up time trying to make this.
That's right. I can grab it and display it. So, yeah. So yeah, NA they do know, and QOP likes to play this little game where he's like, he doesn't believe that it was real, but it's just a game. He's good.
Doesn't believe what TFE?
Yeah, the trip to Antarctica.
If you pay me, I'll pretend it's real.
No, you pay me. So people, you know that QOP pays me to boost him, right? It's not a well-kept secret, really. So.
Well, so promote my channel. Jeez, come on.
I do. That's. That was tonight. That was part of my required.
Again.
Yeah.
QOP says he pays you in sexual favors. Can you confirm that for us?
No, I can.
All I do is pay him attention.
I have. Yeah. Here is the invoice, from July here. There you go. To KeeKoPip.
Does that cover your escorts in Las Vegas that you got last weekend?
No, I was in Regina last weekend. Oh yeah. Yeah.
That was her name.
Bill to KeeKoPip, Premier Flatter Thought Leader. June payment paid in full. Very nice. We've got he did increase his services here. We've got the monthly recognition package as the best Flerf on the globe. Spotlight, curated missions, strategic platform elevation. That's tonight, right here. That's what I'm doing. We got this debunker to Flerf crossover traffic, routing, and comment section visibility boost. All this good stuff. The standard package, the ego maintenance retainer. So anyway, the bill. In fact, he's paid July already, so we're good on July. So thank you for that.
Does he have the recursive coding on there?
He, in fact, does not have any recursive coding.
You guys are just trolling me now. You guys think you're so cool and knowing what that means.
So
in a general chat now.
No, I don't know where you put it. Oh, there it is. I see it now.
Yeah,
I see it
believe
now.
This guy's the air.
Okay.
This guy's the air traffic controller. He can't figure out Discord.
All right. No, he did. I was looking in the wrong place. So here is this is Australia. It looks like, right?
Yep.
And
so basically, you're looking at our radar picture that we see. We can look at all of the airspace controlled by Australia, which is about 11% of the world. But I want you to have a look at those headings. They're bearing lines. They're bearing lines that we would use on a target, and we would tell an aircraft which way to fly, right? I want you to have a look at particularly the 90-degree ones that go across the page. There's one that's on the left that actually.
How do we look at this?
The up and down ones? Yeah. Okay.
Up and down a 360.
Can you post it? Can you post it in my main text or something?
Yeah.
It's in the side chat. You want?
It's okay. I'll put it. I'll put it in your main text chat as well.
Yeah, I have no clue how Discord works on my iPad. Sorry.
That's okay. Okay.
So you're saying we don't use a globe for air traffic or for navigation for purposes in that? I can show you hundreds of things that will prove you wrong, but I want you to have a look at this one first. I want you to tell me why a system would be so messed up that you would give a heading to an aircraft from a position at the end of that line that says 90 degrees when it's actually going northeast or southeast. Can you see how they turn?
That's the one that says
the one on the
3135.
The one on the left that says 090 up the top of the page on the left.
Okay, got it. Yeah, that's
3135 is the distance, and 090 is the heading that we give to the aircraft. So why would I give a heading of 090 from an aircraft that's down the bottom of that bearing range line if it's going northeast from its position on that map?
What is the heading? Is that's like the compass direction?
Yeah,
it's you can fly it magnetic, or you can fly it. What's the other one? Shit. Normally we give magnetic headings to an aircraft, but they can be true as well.
Yeah.
Right. So what if the magnetic lines aren't going? What if they're different than the declination map we got?
Yep, we account for declination. This is.
But what if right? So what if you're accounting for? What if you're not accounting for what is declination? What if you're accounting for what is your map is fucked up?
Then you'd crash. Yeah, you'd get lost. People would die all the time.
I'm saying like let's just use our thinking caps real quick. Imagine the map is different than we're given, and to get you to navigate correctly around the wrong map. That's not the true map. I just tell you the magnetic declination lines are a certain way, so you do travel in the correct directions.
So if I put a bearing range line on a position like Perth, I can click on Perth and then I can click on Sydney. I can give you to the point mile accuracy of how far apart it is between those 2 points. But I'm not caring about distance at this stage. I'm talking about headings. Why am I giving a heading to an aircraft that's right down the bottom of left part of that photo? Why am I giving a heading of 90 degrees when it's almost facing northeast? It's probably more northeast. Yet the one on the right side, near Tasmania, down the bottom of where the island is, why am I giving a heading of 90 degrees to an aircraft that's on the left side of that bearing range line to go southeast when it's heading 090? Declination doesn't account for that much in around Australia. We have probably about anywhere between 4 and 10 degrees. But these are magnetic headings. It makes no difference. If you kill declination, it's magnetic. Why am I giving that heading going southeast?
You would agree the only reason you trust the magnetic declination map is because we get to places in the correct distances and times and directions, right?
Yeah, that's fantastic evidence. Really good evidence.
So real quick, so you don't actually know the magnetic declination line, you just know that it works.
We have an adjustment every year. In actual fact, it can be 3 months.
Yeah, the adjustments don't mean that the map itself is not entirely warped. So the warping can be like it can be fluctuating.
Sorry, I'm getting a delay every time I speak. I'm speaking over the top of you. I don't mean to.
Well,
so if I'm sitting on a runway, and I know what my heading is off the runway, I have a declination adjustment that I can use at that runway, and I know exactly what that difference is. Like Melbourne, I think is 8 degrees. So I know what the declination is. That's not an excuse. You're talking about
you're
90 degrees there, though. And why am I 360 splayed to the top? Why aren't they pointed to the center?
You're confusing, like you're mixing declination like as
You're talking to someone who
we're
teaches
given it.
navigation, by the way.
So when I know, but what I'm saying is like the entire map and the map could be like different. The declination map could be different, but you're given two of these things that work together to make it possible for you to travel around a map that's not the one you're given, because the declination map is warped to adjust for all the inconsistencies of the map that you're given. And the only reason that you trust both maps are correct is because they work. But they would work if you were given a
So
wrong
you're
version
saying
of
air
both of
traffic
them.
controllers and pilots use maps that are incorrect? Is that what you're trying to tell me?
If your map was incorrect, all I would need to do is tell you the declination lines are like this. That way you travel in a different way, because you think it's magnetic declination being, turning and stuff. But it's really just you need to turn, adjust for the map's inconsistencies. That's just my theory. You know what I mean?
It's a poor theory, mate, because I can tell you now what the declination is. Have a look at the one in the middle that says 090646. It's just probably south of Adelaide.
Yep.
That one's actually heading 090, heading southeast, and the declination of Adelaide is around 12 degrees. So how would I possibly be giving an accurate heading to say fly to, that looks like somewhere over in on the east coast there, probably Benalla. Why would I be saying fly 09 heading to Benalla off that heading when they're going to go completely the wrong way?
It's hard for me to honestly visualize exactly which one you're talking about, based on what you're saying. But the main thing is all these things really can the adjustments for AE versus globe, wouldn't be that. I don't know why that's so difficult for you guys to comprehend how easy it would be to convince people of a globe from an AE map. The only thing that would debunk the AE model is pretty much going south, and they're circumnavigating south. So that's
or angles or distances too. Yeah.
Let's talk about a flight from Punta Arenas to Wilkins Aerodrome. A flight that I have a friend flies 4 times a year, and a flight that I've actually flown with myself and I've tracked as a comms operator in Antarctica.
All right,
I'll punch in any flight coming up.
I've got my hold on a sec. I've got my my AE map here ready to go. Can you see it? Does it show up on your screen there? Zoom array.
Oh, I have to go to YouTube and mute myself on mute.
Well, I'm sharing. I'm sharing to Discord too, but it might be hard to grab on a iPad. But I've got the AE map up, so you could, if you've probably seen it before, you can visualize where it is. You can have me. I'll be your hand. You tell me where to put the beginning and ending of the flight, and then I'll draw a straight line between them.
So these people work in. They work in Canada.
Quick, before you guys, really quick. So before you guys scrutinize the AE map, when I say AE, I'm just talking about the North Pole centric model. So that's the only thing I represent or defend.
Yeah, that's the AE map.
The AE map or the AE. So yeah, but the AE map we're given specifically is just a globe. So it just comes from the globe map's projection of the north centered, map. So if I believe that the globe map is incorrect, even if it's projected from the north, so in many different ways, I have different theories for how those different ways are laid out. But so I don't really defend the exact AE map we're talking about.
So would you suggest then queue up on an AE map that it's wrong, and maybe that North America is over here and that Australia is here? How could this?
No,
it can't be if it's North. Hold on, queue up. If it's North Pole in the middle, you don't get to change the relative positions of the continents.
Yeah,
they don't get to change.
So as far as a lot of the things, so primarily around the northern hemisphere, it's probably all pretty close to being accurate. Maybe there's a little bit of some morphing going on, but probably not that much. But as far as like the southern hemisphere, like that's pretty much just the globe spread out, and it's not. I don't know how inaccurate that is, and I would assume that there's more land that is not on that map.
I'm about to show you how inaccurate it is.
All right, so yeah, where's the beginning of the flight?
Yep, Punta Arenas, right where you're pointing.
All right, good. All right, and
so
then
we got pilots who fly a Basler, a BD-67. It's a DC-3 aircraft from World War II with modern engines. They've come from Canada, by the way, but they're down in Punta Arenas. They're about to fly to Wilkins Aerodrome, which is the red dot that Mike just put over south of Perth. It's roughly around there. When they take off, they land and refuel twice, but they take off south and they fly over water. And shortly within the flight, you're going to see icebergs and snow. Why, on a flat Earth, would you be taking off in completely the wrong direction?
So you're saying that one circumnavigates south?
They go south. They fly directly over the South Pole. They fill up with fuel two places. One is a British station, and one is the South Pole. And then they get to a place called Wilkins Aerodrome, which is where I've worked. How do they do that? When the distance they know is 3,523 nautical miles, and we know exactly how much fuel and when to fuel up and where.
Well, obviously they go here, right? And then they go over the red part, and then over the part outside the red, and then they get to the outside here, and then they magically teleport up to this other side here, and then they
That's a dual pole model,
right? And then they Pac-Man it, and then they go over the red part again, and then they land at the aerodrome. So
all right, there you go.
There you go.
That's the flat Earth.
That's how they do it.
Representation.
So it doesn't really matter where any of these continents are at all, because they start here, they go south, they keep going south till they get to the South Pole, where they refuel and keep going. That's all right. We figured it out. We figured it out, Zoomer Ray.
There's obviously many possibilities of what's going on, right?
No.
Some are more conspiratorial. Some are more conspiratorial than others, but you guys are obviously
Well, obviously
any possibility.
Obviously, the right one is the one that works. And so, if you say, "Well, let's test it," which way should we go, and how long is it if we use the globe? Well, according to the globe, we should fly south, and it'll be this long, and that's the direction they went, and that's how long they flew. So we'll just use rationality and logic and say, well, the globe matched, and there is no answer for flat Earth. So anyway, I don't want to keep you longer, QOP.
But what is it? What kind of flight is this? Is this a commercial flight? Like, who is this? Who's taking? Is it like a private airline?
These are pilots that fly for Kenboric Air. They're leased by the Australian Antarctic Division, and they fly all around Antarctica. I was a comms operator there, and I literally tracked their flights. So it's pretty weird that you'd say that, because if they crashed and I had to call a search and rescue on them, you're saying that I wouldn't know where to send them. You wouldn't. I wouldn't have a clue where to send search and rescue to find these guys.
Yeah. So here's the main thing, right? So this is a conspiratorial take, right? So like, if the world is set up somehow like this map suggests, Antarctica being the debunk of that setup would be the thing that's basically the most basically lied about. So the fact that that soothes my mind from race thinking about like what possibly could be going on there when you say it's not a commercial flight, it's just an Antarctic flight, which is obviously controlled. So yeah, I don't know.
You can take this flight if you want to. You can go down and do this flight.
100%.
You can go. There's 5 companies that do it.
I get told that a lot, but I don't really believe that I'm allowed to go all to Antarctica.
You didn't try it.
All of those flights.
Yeah, you should try.
Yeah, I'm down. I'm not going to pay for it to find out, but I would be down if someone
he's super committed. Super committed to truth.
Anyway, Mike, I'm going to leave you to it. Get back to work. Catch us later.
All right, thank you. All right, well, that was pretty cool. Another flat Earth destruction. Thank you, QOP.
Come to Punta Arenas in December.
I want to.
I have a girlfriend, Max, but thank you for the offer.
Hold on a second. I gotta play this again.
Number one, no, you
Man,
don't.
waka
And
waka
number
waka
two, why
waka.
like you're coming back, right?
Who's coming back?
If you go to Punta Arenas, like why is having a girlfriend an impediment? You just
I'm
her
not,
for
Max.
a
I'm
week.
very honored, but I'm not interested. Thank you.
Okay. That says
I
more
hope you
than
find
can.
the male lover
That
that
says
you're looking for.
that says a lot,
not
Q up.
KeeKoPip.
It says a lot, Kiko.
It
All right.
does say a lot. It's affordable. It's way more affordable than
I'm
than
sure you would
Antarctica.
pay for all the expenses and treat me like the woman that you want me to be, but I can't be that for you.
Oh no, Keeko, you're doubly. I mean, you're doubly disqualified. Number one, I don't roll that way, and number two, and more importantly, I don't do that.
This is why I shouldn't have taken the sleeves off my shirt. I've aroused too many of your gay Glober followers.
Oh my god.
No one bit. You give people D erections.
I've led you on, and I apologize for. I don't want to break your heart, Max, but I can't travel to your whatever in South America you live, you weirdo.
KeeKoPip.
Hold on a second. Arwen has something to say about this. Hold on.
Arwen?
Arwen, yeah, Arwen. Here it is.
It literally makes my dick go soft.
There you go.
His voice is worse than Max's, dude.
Oh. Arwen.
Max's voice is fine.
Arwen, you're so awesome.
I do my best.
Yeah, thanks.
Wait, what was that? Did you have a soundboard for that, or is he talking?
Well, I don't know. Sometimes I like to do you know Arwen likes to sing? Like, what's your favorite MC Hammer song? You can ask him. Ask him what his favorite MC Hammer song is.
Can't touch
I'm asking.
Can't touch this.
Wait. Classic Hammer Time.
Oh no.
Oh, you're so funny. All right. Well, KeeKoPip, you were headed out. I don't want to keep you. You've been great. Thank you so much. Always great to talk to you.
All right, adios.
All right. Seer Soul, you were saying something? I'm ready to
no, I
wrap
was
up.
just gonna ask what Arwen's favorite song was, but it was already.
Yeah. He gets confused sometimes.
I don't really know what I'm doing.
Man. Arwen, do you find it hard to get food at the grocery store?
Some fresh lemon juice.
Oh no!
Yeah, with the lemon that's been sitting there for a while, and was going bad.
Cute.
So,
I think I have one for. I'm loading. 1 second.
Okay.
Come on.
Jack Fetter. Jack Fetter says Newton's life work could have been so much more prolific, but he always bailed on experiments. Bro, I have a girlfriend. Hashtag QOP Alpha Virgin.
Yeah, I am the citation. Get the fuck out of here, dipshit.
Thank you, Arwen.
Inquisitive Infidel says, QOP, why bother if you're impervious to evidence? Because it's fun. It's fun. Oh.
Do you want one more?
Yes, one more.
Donate to my PayPal or fuck off.
that will get you donations.
That's it. That's how to do it. Now, sometimes Arwen is honest, and he gives us a little insight into his real deepest thoughts.
Flat earthers are stupid and retarded, and they never pay attention to anything, and they always get things wrong, and they're lazy, and literally all that.
There it is. Okay. All right. Well, I'm gonna let you all go. By that, I mean you on YouTube. If you want to join in the fun, the link to KeeKoPip's Discord server is in the description. It's in it's pinned in the bottom comment, the pinned comment. Also, KeeKoPip always wants us to definitely sub to all of his channels, especially his KeeKoPip channel, KeeKoPip. Why is that? Who knows? He thinks it's cool because it looks the same forward and backwards if it's all lowercase, and the descenders on the Q don't have a hook. So choose a font appropriately. But I will stay on for a bit, at least. I'm going to stay on the Discord server if you want to pop in and say hi to me and chat a little bit while I do some other stuff. But everybody else, in YouTube land, you're going to need to, you don't have to go home, but you can't stay here. But you can become etherically displaced.
What is a full moon and what is a new moon on your model?
Probably like a magnetic cycle, and just like the center of a ferrocell cell image of a magnet.
I think it's probably like a magnetic cycle, just like the center of a ferrocell spiral. Image of a magnet. It's just
Yo,
black
Tay,
in
have
the
you
middle.
ever thought
It's
about dating a
actually
flat
pure inertia, not just a little. In the ferrocell image of a magnet, it actually goes into its inertial state.
No.
Then charges back up. It becomes like etherically displaced.
Absolutely not.
Yeah.
How about now?
See it charge up once more, and it goes back like it did before. Once it becomes like etherically spaced, you see it charge up and take its place.
I mean, it does when it comes from me.
That's how moon phases work, fam. Pass the dresser. In the magnet's heart, centrifugal divergence flies. Centripetal convergence pulls. Defying all science, etheric whispers sing. Light and shadow blend.
The song
Magnetic
dropped out.
cycles spin, where physics seems to end. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It
What
becomes
about
like
an ex-flat earther like
displaced.
Jaren? Would you consider that?
Grab your partner, swing him round, magnetic cycles up and down. Either song in the air, hillbilly science everywhere. Cause it's like etherically displaced. Yeehaw!
What is it? Are
To the
you
Wixit word salad buffet. Who has light vinaigrettes? It's behind the Jugger Ranch.
I can't believe I won my first
And charges back
interferometry
up, and once
debate.
it becomes like etherically displaced again, you start
At
to see it
KeeKoPip.
charge up throughout a cycle, and it goes back.
I don't know. I think perfect storm's coming in to take your win streak away.